projects. In this video, we are going to explain about the project, which is identifying fraudulent credit card transactions using ensemble-based learning. So before getting into the execution, first let's understand what is the project. So we all heard term called credit card fraud, right? So let's get deeper into it. Credit card fraud. It has become a serious issue in today's world, especially with the rapid shift towards cashless payments. So think about how often we use this credit card. So we use it whether it is online shopping, paying bills, or even buying groceries. As convenient as these payments are, they also have opened the doors for fraudsters to exploit the system. For example, imagine you are casually ordering food online, and a few days later, you notice suspicious transactions on your credit card statement. This is a common scenario that many people face, showing how easily fraud can happen without even realizing it. Despite many banks, that means despite the security measures that banks and credit card companies implement, like OTPs, that is one time passwords, or fraud alerts, fraudsters still manage to find loopholes. Some might clone credit card details from online purchases, while others launch phishing attacks to trick users into sharing sensitive information. Even though financial institutions invest heavily in preventing fraud, it remains an ongoing challenge. Fraudulent activities not only cause direct financial loss but also shake customers' trust in digital transactions. This is why detecting and preventing these transactions is so critical in today's fast moving digital landscape. In 2020, credit card fraud resulted in loss of $28.6 billion, according to the Nielsen report, highlighting the serious impact of fraud despite banks' efforts combat it. Initially, fraud detection relied on traditional statistical models. So, initially, fraud detection was dependent on statistical models. But these have now evolved into more advanced machine learning techniques that can classify transactions as genuine or fraudulent. So, machine learning models were also used to detect these frauds as genuine or fraudulent. But problem with these models is they still face challenges like class imbalance. So they face the challenge class imbalance with many more legitimate transactions than fraudulent ones. That means class imbalance means we'll be having genuine transactions more than the fraud transactions and the rapidly changing tactics of fraudsters. So to improve accuracy and reliability in fraud detection, there is need for robust ensemble techniques that combine multiple models to better adapt to these challenges. So to tackle all these challenges, in this project, we propose ensemble-based methods. So to tackle the challenge of credit card fraud detection, ensemble methods have emerged as a promising approach. These methods work by combining multiple models into one single model. So here we'll be combining multiple models which can lead to better prediction accuracy than using a single model on its own. So the project focuses on overcoming the limitations of individual classifiers by exploring different ensemble techniques. One is bagging and boosting. So coming to bagging, we'll be using random forest. Coming to boosting, we'll be using XGBoost. Additionally, we incorporate data balancing method, that is, we incorporate multiple data balancing methods that are oversampling, undersampling, and smooth. Help address the issue of class imbalance where there are more genuine transactions, that is legitimate transactions, than the fraud ones. The ultimate goal of this project is to identify the best performing model for accurately detecting fraudulent transactions. By doing this, we aim to help banks reduce financial losses and increase trust in digital payment systems, ensuring that customers feel safe when using their credit cards online. As an extension to this project, we have incorporated tagging classifier, which is an ensemble based classifier. So it combines decision tree, bagging classifier, and LGBM, that is nothing but light gradient boosting machine, to enhance prediction accuracy. So by aggregating the outputs of these different models, we leverage their individual strengths for improved results. Moving on, we have developed front end using Flask framework. So we have used Flask framework to develop the front end. This interface allows users to interact with the system easily, and we also incorporated user authentication mechanism in the front end. So this will ensure secure access, safeguarding user data while providing a functional and user-friendly experience. This combination of advanced modeling and an intuitive interface enhances both the accuracy of fraud detection and also the overall user experience. Moving on, the implementation of the project. We have followed these steps to implement the project. Let's understand each step. So first, we have imported the required packages such as NumPy, Pandas, scikit-learn, etc. Then we have loaded two datasets. One is European dataset and Sparko datasets. That means we have used both the datasets to predict the frauds. That means to detect the fraud. And then we have explored all these two datasets to understand the structure and the data types of the dataset. After understanding the European dataset and the Sparko dataset, then we have performed data processing where we remove duplicate values, we clean the dataset. Then we visualize the dataset. After visualizing, we select the important features using PCA technique, that is nothing but principal component analysis. After selecting the important features, then we append the features to X column, that is the X variable, and target variable to Y. So here, we'll be splitting the data into two variables. One is X and Y, where X will have the features and Y will have the target variable. To tackle the issue of class imbalance, we have used three different techniques. One is oversampling, undersampling, and smooth. We will be sampling the data with all these three techniques, and then each individual model will be building with the each sampling technique. Moving on, then we split the data into train and test sets where we use train for training the models, test for evaluating the models on unseen data. After splitting the data, we train and build the models. We build and train the models to predict the credit card fraud. And then we evaluate all those models using accuracy, precision, recall, and F1 score. Then we compare all the models using comparison graphs of all these metrics. Then we have developed front using Flash framework. And then we also developed an authentication mechanism for secure login. Then in the front end users, they will be giving the feature values, that is the input. After giving the feature values, those will be pre-processed in the backend to predict the credit card fraud. And those pre-processed values will be fit into the trained model and then final outcome will be displayed through front. Moving on to the algorithms used, we have used random forest, which is proposed, that is bagging technique, XGBoost, which is boosting technique. These both are the ensemble models. We also have used naive Bayes for comparison purpose. We have used voting classifier. It is also an ensemble model. And the extension model is tagging classifier, which combines decision tree, bagging classifier, and LGBM, that is light gradient boosting machine. So this tagging classifier has performed well, so we have deployed it in the front end to make the predictions. So this is all about the theoretical concept. Let's get into the requirements. To implement this project, we need hardware and software requirements. So coming to hardware requirements, we need operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. And software requirements are application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3. Front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. So now let's execute the project. To execute, we need to open the code folder which contains source code files. Let's open code folder. So these are the source code files in the code folder of the project. Let's understand each of them, how will they be used in the project. So let's open the first folder, which is European, in that we have the data set. It is taking a while, it's buffering as the data set is large. Let's minimize it. Let's open other data set until then. So let's open this. This is the Sparko data set. Both are loading. Until then, let's understand all the other folders, then we'll get back to this. So this is a static folder. This folder comprises of a CSS, JavaScript, and Bootstrap files. These files are important for the visual interactivity, that is visual representation of the project. So coming to templates, this folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And this is app.py file. This .py file contains the information related to front-end logic of the project. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content that to be rendered in HTML templates. And this is the notebook file. This is the Jupyter notebook file which contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, which makes it a popular choice for the data science. So here we have notebook files. One is European and the other one is Sparko. So in this notebook file, that is European notebook file, we'll be having the dataset of European, and all the models will be trained on European dataset to predict the credit card fraud. And coming to this Sparko Jupyter notebook file, in this file we'll be training all the algorithms on the Sparko dataset. And these two are the model files which contain the algorithm information. So these will be loaded into the project code during runtime of the project. And here we have two sample files, two sample Excel files in which we have the test cases. So those test cases will be using in the front end to predict the credit card fraud. So let's check whether files have been opened or not. Yeah, so here if you observe, this is the European dataset. So this is a European credit card dataset. Here, all the features are named as V1, V2, V3, V4, etc. It is for the security purpose. All those transactions, all those values are very confidential. So that is why they are named it into V1, V2, V3, and V4. So here if we scroll right, here we have the amount column. This is the transacted amount. And here in the last column, that is the target label where we have 0 and 1 classes. 0 refers to non-fraudulent transaction and 1 refers to fraudulent transaction. So we'll be using this data to train the models. So close this. Back to the code folder. So this is the signup.db file, which is the database file, which is used for storing the user information. Now to execute, we have to copy the path of the code folder from the address bar of the file explorer. So copying the path. We have to open the Anaconda prompt. So Anaconda prompt has been initiated. Now we have to use the command cd followed by the space. Easy copy. Now click on it. Then if you observe, current directory is changed to the code folders path. Now we have to compile app.py file. So give the command python space app.py. And now click on enter. So this command, it will execute the Python script and check for syntax errors and runtime check. And it will perform the runtime check and check for syntax errors or logical issues. After running the app.py file, Flask framework will host the application at the default address, which is the local host and the port. So this is the local host and this is the port. Now copy this local link provided by the Flask framework and paste it into any web browser. So I'm copying the link. I prefer Google Chrome, so I will paste it in that. Paste the link here, click on enter. And this is the web page of the project, which is displayed in the browser, and this is developed using Flask framework. So we have to sign up first, so click on sign up and enter all the registration details if you are registering new. I have already registered, so I'll directly sign in, so click on sign in. I'm supposed to provide the username and the password. So give the username and the password. Now click on log in. We have logged in successfully and we are redirected to the prediction page of the project. As we are as we are training algorithms on both the datasets, that is Sparko and Europe, so we'll be doing prediction for both the datasets. So let's do prediction using European dataset. So click on that. So here you can see parameters right? We need to enter all these parameters and then click on predict. Based on the given inputs, then we will get the prediction whether it is a legitimate transaction or a fraudulent transaction. So we have already discussed regarding the inputs to be given in the front end, right? So that we have in the sample folder. So as we are doing prediction for the European folder, we have to open the sample Europeans, open it. It's taking a while, just wait for a minute. So these will be using them as the test cases, the front end. Enter the parameters. We have to enter all this V1 to V8 values. So copy the V1 value. So this is the V1 value and here we have to paste it. V2, V3, V4, V5, V6, V7, V8. Here, if you observe, we have class as 1, which means that it should be the fraudulent transaction. So let's check whether the application, it will correctly predict or not. So click on predict. Buffering, it's taking time to pre-process. So we have given the input. So based on the given input, here the application has predicted as credit card transaction. It is a fraud transaction. So if you observe, application is correctly predicting the inputs. So that means it is correctly predicting the credit card fee. So now let's give other set of input. So select the European, keep it aside. Let's test using the 10th test case. So copy the V1 value, paste it here. V2, V3, V4, V5, V6, V7, V8. So here we have class as 0, which means that application, it has to predict that there is no credit card. I mean, there is no fraud transaction. So let's click on predict. So if you observe, credit card transaction is legitimate. That means that it's a genuine transaction. It is not a fraud transaction. So let's try using some more test cases. So let's try using this 20th test case. So let's again click on prediction, click on European. Copy it, paste it in the even place. The next one is V2 we have to give the V2 value, V3, V4, V5, V6, V7, V8. Let's see what is the outcome should be predicted. That it should be predicted as 0, which means that no credit card. So click on predict. So here the application has correctly predicted that credit card transaction is legitimate. That means it is genuine. The input which will be given, it will be pre-processed at the backend and it will be fitted with the trained model and we will get the prediction after the trained model predicts the outcome. So this is all about the European dataset. Let's try with the Sparko dataset. So click on Sparko. So these are the parameters that are need to be entered for this Sparko dataset to predict the credit card fraud. So let's enter them. We also have test cases for the Sparko dataset. For that, open the code folder, the Sparko file. We need to give all these inputs. So for that, the file is being loaded. Just wait for a while. So these are the some of test cases using which we'll be detecting credit card fraud. So let's enter all the parameters. So the first parameter, which is transaction year, is 2019. So let's try using the first test case. So the transaction year is 2019, where transaction has been done. So the transaction month is 7th, which is a September. Transaction day is 2nd September. And the date of birth year is 1964. Date of birth month is 11th, that is November. And the 17th day. Category is 12. So here we have to select, I mean, count and give the number 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it is shopping net. So select shopping net. Here he has used his credit card for the shopping net, and here we have to provide the amount that is 7.2. Give the zip code. So the zip code is 6441, and here we have to give the city pop that is 5438. Click on predict. So here for the first test case, it has to be predicted as genuine transaction because if we observe here, we have the value 0. So let's see application is correctly predicting or not. If you observe, it has correctly predicted that is credit card transaction is legitimate. Legitimate is nothing but it is genuine transaction. So let's try using other test case for the same data set. So let's try using the 7th test case. So the transaction year is 2020. Transaction month is 3, that is March. Transaction day is 11. Date of birth is 1976. Date of month is 2, that is February. Day is 26. And here we have to choose a category as 8. Let's count 1, 2, 3, 4, 5, 6, 7, 8. So that is kids and pets. And here we have to provide the amount, that is 94. And here we are supposed to provide the zip code, that is 82514. And here we have to give this city pop, that is 1645. Now click on predict. It has to be predicted as legitimate, that is genuine transaction. So whether, let's see, application will correctly predict as genuine or not. So here it has correctly predicted that credit card transaction is legitimate. That means that it is genuine. Let's check with the other test case, that is the 7th test case. So provide the transaction year, that is 2019, transaction month is 11, transaction day is 17, date of birth year is 1928, date of month is 4, date of day is 2, and the category is 8. So 8 would be kids and pets. And zip code is, so sorry, before that we have to give the amount, that is 504.27508. Select the zip code. For that we have to give as 686841. 68641 it is actually. And here we have to give the city pop, that is 1063. Now click on predict. So here we got the prediction as credit card fraud transaction detected. That means credit card transaction is fraud. So it has correctly predicted. Here 1 means that fraud transaction. So here application has correctly predicted the credit card. So now let's stop doing the prediction. Now let's check with the graph. So click on graph. Let's check for the European graphs. So this is a sample outcome graph where on x-axis we have classes and on y-axis we have amount. Here 0 represents the legitimate transactions, that is the genuine transactions, and the 1 represents fraud transactions. As there is class imbalance, so that is why we have used oversampling, undersampling, and smooth technique. And this is the correlation matrix, that is the correlation between the variables. And this is accuracy graph for the oversampling technique. So here on x-axis we have accuracy score, and on y-axis we have all the algorithm names. If you observe, stacking classifier, that is the extension model, is achieving the highest accuracy. And this is the precision score, this is recall, and this is F1 score. Accuracy, precision, recall, and reference score are all the error metrics that are used for checking the absolutity of the classification model. So here we have the undersampling techniques, accuracy graph, precision score, recall score, and FN score. And here we have for the smooth technique. So this is the FN score, this is the recall, this is the precision, this is the accuracy. Let's check with the other data set. So click on Sparko. This is also the sample outcome graph for the Sparko data set. Here we have the correlation matrix. This is the oversampling. This is the precision, recall, FN score, and RL score. Here we have the undersampling techniques, accuracy graph, precision, recall, and FN score. And here we have for the smooth technique, precision, recall, and score. Among all the graphs, you can observe that stacking classifier is having the highest metrics. That means highest accuracy, highest precision, highest recall, and highest FN score. So now click on sign out. So in this way, by using the ensemble models and using the sampling techniques, that is the data sampling techniques, we will be able to correctly predict the credit card fraud. This will be helpful to all the financial institutions and also the customers who use their credit card. This is all about the project.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.